Have you ever been taught how to multiply matrices, but you've never really understood what it meant or what it represented? Let's start with a typical example. This is a 3x3 matrix being multiplied by a 1x3 matrix, and the result is a single column vector 1x3 matrix. But what does that look like geometrically? So by geometry we just mean existing within space, so we've got points or positions and we've got directions. So this is my first animation. I hope you like it. I think it looks pretty cool. The initial vertex position is 2, 3, 4. The resulting vertex position is 10, 15, 20. I've added in 3 little sliding colour markers which just nicely animate and slide along each of the 3 axes as the calculation also animates. And we've also got this pink direction vector which also follows the current position of the yellow vertex. So let's move on to the animating cube example. I've added 7 additional points. It's not a cube, is it? It's a cuboid. I've added 7 additional points. Each one of those has got the same initial value, 2, 3, 4. You might ask yourself, what does it even mean to scale a single point in comparison to this cube? There's no difference in principle. It's just the distance between the point and the origin where the 3 axes cross over at 0, 0, 0. So the distance from 0, 0, 0 to any point is the distance that's being scaled, and it makes no difference if you've got one point or multiple points forming a shape. So we transform the initial vertex position by following the rules of matrix multiplication. Notice that the 3x3 matrix has got 5s going down from the top left to the bottom right. If you look at the calculation as it progresses, you'll notice that the number 5 in the first row corresponds to the x value, the number 5 in the second row corresponds to the y value, and the number 5 in the third row corresponds to the z value. So we should also take note that if we replace the 3 number 5s with number 1s, we're left with an identity matrix, which is just the default matrix to keep all the values the same. If you look at the multiplication, you'll see that the number 1 simply leaves the 2, 3 and 4 to be the same value, and therefore there is no animation, so yes, it's rather boring. So we've got the column vector, which is the yellow vertex, and we've also got the 3x3 matrix. Now, what does the 3x3 matrix represent? We know that the column vector is simply the position of the point, which we also sometimes call a vertex, especially in computer graphics. But the 3x3 matrix, the scaling matrix, what is that in terms of the geometric representation? The answer is the 3x3 matrix contains each of the 3 axes. So we've got the left column, which contains the x-axis, we've got the middle column, which contains the y-axis, and we've got the right column, which contains the z-axis. Now you can think of the 3x3 matrix as a scaling matrix because it scales the position of the point, but you can also think of the point as scaling the matrix. But to do that, and to see it geometrically, we need to draw the 3 axes to start out at length 5, and then the length of the axes extends along with the position of the point. That makes sense because you've got 2 entities. You've got the 3x3 matrix, you've got the 3x1 matrix or the column vector. After the multiplication, you've just got the one entity, which is the column vector. So it makes sense that they merge together in that way, which you can see geometrically. So that's it for this tutorial. The next one's going to be on rotation matrices, so that's still a 3x3 matrix. Please give us the thumbs up and please don't forget to subscribe, and I'll hope to see you next time. Or I hope you to see me next time.